In our video for today, I will be discussing the shear and moment diagrams in beams. Now, itong lesson na to was already discussed in your mechanics of rigid bodies. However, ginagamit pa rin to sa structural theory kasi it defines the loads and moments acting sa beam natin. And so, meron akong steps dito na we will follow so that we can draw the shear and moment diagrams sa beams natin. Now, the first step is to assign letters where there are changes in loads as well as at the ends of the beam. So for example, you have this beam and then let's just say it's simply supported. Let's just say it's overhanging, ganito, and then merong load dito na uniformly distributed, and then dito merong concentrated load. You will assign letters sa ends ng beam. So we will be assigning letters for this one and this one. Now let's just say this is point A, itong hinge support, and then yung end ng uniformly distributed load is another point. And so let's say this is B. And then since dito meron tayong concentrated load, merong change in the loading. And so this will be another letter. So let's just say this is C. And then diba overhanging. So let's say merong support dito. This will be point D. And then dito sa free end, kasi that's another end of our beam, that will be another letter. So let's just say that's E. So, ganyan. And so, ganyan yung pag-label natin sa beams natin. And then, yung next step is to solve the reactions. Kasi, diba, our beam is in equilibrium. And so, kailangan natin yan to proceed to step 3, which is the formation of the shear and moment diagram. And then, these are the things that you have to consider. First, always draw the shear and moment diagrams from left to right, never right to left. Now, that's because of our sign conventions, which I will discuss later. And then, if a beam is determinate, its reactions are easily solved by static equations. Summation of forces vertical, summation of forces horizontal, and summation of moments about a point. However, if the beam is indeterminate, it will take additional equations to solve the reactions. Now, itong additional equations, we will be discussing this in the future. Kasi meron kasing iba't ibang methods. Meron tayong double integration, area moment, saka marami pa. And then, it's used to solve the extra reactions na hindi kayang isolve through static equations. And then, meron pa tayong considerations. There are left and right shear values at concentrated loads and left and right moment values at moment loads or reactive moments. Now, sir, ano yung ibig sabihin nito? Let's say we have this beam na ito. Let's say this is simply supported, and then merong concentrated load at the midspan. So, diba, let's say this is 1. Yung reactions natin magiging 0.5, and then dito 0.5 din. And then if we will draw the shear diagram, then ito yung mangyayari. Diba, let's say this is our zero line. At this portion, aakyat tayo ng 0.5. Kasi diba, this is upward. So akyat tayo ng 0.5, and then since walang load dito, we will just draw a straight line. Kasi constant yung shear natin up to this point. However, if we reach this point, then diba, bababa tayo ng 1. Yan yung ibig sabihin ng right shear value. Kasi itong 0.5, this is the left shear value. And then if bababa tayo ng 1 dito, diba, it will become 0.5 minus 1 will be negative 0.5. Now, itong 0.5 dito, this is the left shear value. And then itong negative 0.5, this is the right shear value at this point. And so, let's just say this is A, this is B, and this is C. So, itong 0.5, this is VBL, or the left shear value at B. And then, itong negative 0.5, this is VBR, or the right shear value at B. Yan yung ibig sabihin yan. And then, kung dito tayo sa moment values, it will affect our moment diagram. And so, let's just say we have a cantilever beam, and then merong load dito. Diba, this will have an upward reaction, and then a moment reaction. Now, if we will draw the moment diagram, then diba, dito sa end ng beam natin, it will start at 0. Kasi according to our fourth consideration, the shear and moment values should start and end with 0 values. And so dito sa starting point, we essentially begin at 0. However, because we have a reactive moment dito, then we will have a right moment value. Now, let's say this is point A. Itong 0, this is the left moment at A. So, let's just say this is MAL. And then, this moment reaction, which is counterclockwise, diba, let's say this is 1, assumed value lang. diba, bababa tayo ng 1 kasi counterclockwise. And so essentially, itong negative 1, this is the right moment value. Or let's just say MAR. And then, aakyat yan dito. But we will just further discuss this later na. And then finally, the line or curve on the shear diagram is 1 degree higher than the load diagram. And then the line or curve on the moment diagram is 1 degree higher than the shear diagram. Now, I will just show you some examples later. And so proceed tayo. For the concentrated load at A, the right value of the shear is the shear at the left plus the concentrated load at A. Now, this is just an arbitrary point. And then if we have a distributed load from A to B, then our shear at B will be the shear at A and then plus or minus the resultant of the distributed load from A to B. And so meron din tayong examples niyan later. And then for moment values, the right moment value is the moment value at the left and then plus or minus the moment load at A. However, this won't affect our shear diagram, only our moment diagram. And then let's say we have 2 points A and B. To get the moment value at B, we have to add the moment value at A and the area of the shear diagram from A to B. And so let's proceed sa sign conventions natin. An upward force corresponds to a positive shear. And then a downward force corresponds to a negative shear. And then clockwise moments are positive and then counterclockwise moments are negative. And so yan yung fundamental conventions natin. And then if we will read our areas, we will check the sign and evaluate if the magnitude is constant, increasing, or decreasing. Kasi it's what determines the figure if we move 1 degree higher. Let's say from our load, and then plus 1 degree to our shear, and then plus 1 degree to our moment. We will be considering these cases. And so I have here lahat ng possible conditions ng loadings natin. And so ito na yan. For our load diagrams, this figure shows a negative constant. Kasi it's acting downward, kaya negative, and then it's not increasing or decreasing, kaya constant. So that's why this is negative constant. And then for this one, our load is acting upward, and so that's why it's positive. And then since it's not changing its value, it's considered constant. Again, itong negative just indicates the direction. And then ito rin. And so I hope clear tayo dito. And then if we have a triangular load that increases patungo dito, then that will be negative increasing. Now sir, bakit negative? This is negative because our load is acting downward. And then sir, bakit increasing? This is increasing kasi for this one, we will just be considering the magnitude. Diba, this is from 0 and then it builds up to a certain height. And so essentially, we are starting from 0 and then we will end at a certain value. So again, for this one, we will just be considering the magnitude. And so for this one, this is still negative because our load is acting downward. And then it's decreasing because it started at a certain value and then ended at 0. So kaya decreasing. And then next, we have this load diagram. Now this is positive increasing because our load is acting upward. And then it starts from 0 and then ends at a certain value. And so that's why it's increasing. And then for this one, this is positive because the load is upward and then it starts from a certain value and then ends at 0. And so that's why it's decreasing. And then if dito na tayo sa shear diagram, we will have this one. If this is our 0 line and then we have a positive shear, then this will be positive constant kasi it's above the 0 line and then it's constant. So our consideration here for positive or negative is whether it's above or below the 0 line. And so dito, since this is below the 0 line, this will be negative constant. So lagay ko dito, below the 0 line. And so ito na yung considerations natin. And then if we have this diagram, then it will be positive increasing kasi this is above the 0 line and then it's increasing. And then for this one, this is positive and then it's decreasing. Now, diba, from the load diagram, we will move 1 degree kung nandito na tayo sa shear diagram natin. And so, hindi lang ito yung possible case for positive increasing and positive decreasing. It can also be like this. And so let's say we are starting from 0 and then ending at a certain value. Diba, the connecting line may be a curve. Because let's say yung load natin is triangular. Diba, that's already 1 degree. And so if we will move dito sa shear diagram, it will be in the 2nd degree. And so yung connecting line will be a curve. Parang ganito. Now this is still positive increasing. And then another case for positive decreasing is this one. If we start at a certain value and then decrease to 0. Now medyo may mali sa placement nito. And so move ko na lang. So, andito yung 0. And so, again, these are the other cases of positive increasing and positive decreasing. Now, sir, meron pa bang iba? Meron pa. Kasi, di ba, yung curve, pwedeng paganto or pwede ring paganto. Depende yan sa loading natin. And so, we also have another case. So, pwede ring paganto yung positive increasing. Diba, kanina, it was like this. However, this is still positive increasing because we are essentially starting from 0 and then ending at a certain value. And then for positive decreasing, it may also be this one. And so, yan na yung lahat ng cases natin for positive increasing and positive decreasing. And so, let's move on sa negative increasing saka negative decreasing. And so, ito yung itsura niyan. If our diagram is below the 0 line, then it will be negative. And then, whether it's increasing or decreasing, we will still look at the magnitude. Kasi, di ba, if this is 0 and this is negative 15, di ba, it's essentially decreasing. If we will consider the numerical value. Kasi 0 is greater than negative 15. However, hindi yan yung titignan natin. What we will look at is only the magnitude. And so, di ba, this is 0 and then yung magnitude nito is 15. And so, it's essentially increasing. We will be disregarding the sign. And so, dapat careful ka dito. Again, we are only considering the magnitude. And then for this configuration, this is negative decreasing because we are starting at a certain value and then ending at 0. However, take note that this diagram is below the 0 line. That's why it's negative. Now, just like kanina, meron din tayong iba't ibang cases for negative increasing and negative decreasing. And so, ito na yan. Let's just run through the figures. Kasi na-explain ko naman kanina. So, for negative increasing, it may look like this. And then, for negative decreasing, it may look like this. And then, for our other case, negative increasing can also look like this. Paganto. And then, negative decreasing will also take this form. Paganyan. And so, yan na yung lahat ng cases natin for our Shear diagram, which will also be applied doon sa moment diagram natin if we will move to a higher degree. And so, dito na tayo sa translation ng curves. Kasi meron kasi tayong equivalent lines if we will move to a higher degree. Now, if our load is a positive constant, or let's say this is a uniformly distributed load, then if we will move 1 degree higher, our line will look like this. Now, bakit? This is because, di ba, this is positive. And then, yung degree nito, since it's only a straight line, this is essentially 0 degrees. And so, let's say this is the load diagram. If we will move to the shear diagram, we will add 1 degree. And so, that's why this is already sloping. Kasi this is already 1 degree. And then, this is positive because our load is a positive constant. And so, yan yung tatandaan mo. Now, what if the load is below the 0 line or if the load is acting downward? Ano yung mangyayari? Magiging ganito na yan. Diba, our load is already negative. And so, this is a negative constant. And so, if we have our starting point dito, then our equivalent line for 1 degree higher will be like this. Again, this is 0 degrees. And then, this is 1 degree. And then, it's negative because we are considering a negative constant diagram. Now, itong pinakita ko, this is for the uniformly distributed loads. Itong negative constant is if we have a uniformly distributed load that acts downward. This is what's meant sa negative constant. And then, sir, how about dito sa positive constant? What's meant dito is a uniformly distributed load that acts upward. And so, paganto. However, bihira lang to lumalabas. Now, sir, how about for triangular loads or uniformly increasing or decreasing loads? Ano yung equivalent lines? So, nung undergrad pa ako, ito yung kinoconsider ko na figure. Before any of our exams, nagdo-draw ako ng dalawang leaves. And then, itong leaf na pointing at the right, I will consider that as positive. And then, itong leaf na naka-point towards the left, I will label that as negative. And so, ito na yan. This is positive. Kasi diba, in our normal conventions, yung right is positive and then yung left is negative. Kaya ganito yung ginagamit ko. And so, instead of this one, I will draw my leaf this way. Paganyan. And then, another connecting line dito. And then, for the other leaf, ganito yung drawing ko. And so, now, let's try to remove the leaf. So, magiging ganito. Now, yung next thing na kinoconsider ko is yung nasa right side, that's increasing. And then, yung nasa left is decreasing. So, itong dalawang green, diba, ito yung dalawang nasa right side. And so, yung dalawang yan will be increasing. So, this green portion will be increasing. And then, yung nasa left will be decreasing. And so, decreasing na to. And then, I will just do the same for the other leaf. Again, yung nasa right will be increasing, ito, and then yung nasa left will be decreasing. Now, this is the figure that I'm usually imagining when I am forming shear and moment diagrams. Now, depende na yan sa inyo if you will want to adopt this figure. Again, I will just recap. We will draw two leaves, and then one will be pointing to the right, and then the other one to the left. And then, diba, normally we consider right as positive, and then we consider left as negative. Kaya this is positive and this is negative. And then, for the right side of the leaf, it's increasing. Kaya itong naka-green, which is at the right, and then ito are increasing. And then yung nasa left will be decreasing. And so now, this is what you have to remember when you are forming the shear and moment diagrams. Before we will tackle our example problems, let us first familiarize ourselves with the general formula that we will be using in our calculations. Now, yung first na ituturo ko is yung area method. And then, later na lang tayo sa moment equations. Kasi that will be our introduction to double integration. Now, ito yung spandrel formula natin. Yung area ng spandrel is equal to B, or the base, multiplied by the height, and then divided by n plus 1. Now, usually, so that I won't forget this formula, yung baseline ko is yung rectangle. Kasi diba, let's say we have a rectangle, ganito, and then this is our base, and then this is the height. Diba, yung area nito is just base times height, diba, or length times width, whichever of that. So, diba, if we will be using this one, we have our area is equal to B times H divided by n plus 1. Now, again, for a horizontal straight line, yung degree of curve is 0. And so, yung n natin will be 0. And so, diba, if we will substitute that dito, this will become B times H divided by 0 plus 1. And so that will just be B times H. And then if we will move to 1 degree higher, diba, it will become a triangle. Kasi yung line natin is actually sloping na. So, if this is our triangle, diba, yung area nito is, let's say this is the base, and then this is the height. Yung area is 1/2 times base times the height. And so, applying this one, we have BH, and then over n plus 1. Now, yung n nito, since this is already sloping, this will be 1. And so, diba, applying that dito, we have BH over n, which is 1, and then plus 1. So, again, n plus 1, and then this will be 1. And so, diba, magiging BH divided by 2. And so, this area, dito lang yan galing. But if ever you will forget, you can use the rectangle as your baseline. But usually, yung baseline mo are itong dalawang shapes talaga. Kasi ito naman yung mga common na ginagamit natin sa geometry natin. And so, if ever you will forget, just try to check kung ano yung magmamatch dito. Now, again, yung n is the degree of curve. And then, if n is equal to 1, it will be a straight line. Or, simply ganito. This triangular shape. And then, if n is greater than 1, let's say 2, 3, 4, and so on, it will be a curved line. So, magiging ganito na. Now, again, this is a curved line. But yung degree niyan is not always 2. It can be 3rd degree, 4th degree, and so on. Kasi ganito na kasi yung itsura niyan. Magiging curved na. Now, ito yung general formula for the area. However, we still need the moment arm, or simply the centroid of the figure. Now, sir, how will we compute that? Ito yung mangyayari. Yung moment arm natin, yung general formula na ginagamit ko dito is towards the height. And so, that's why it's indicated here that this moment arm is toward H. Para hindi na kayo malito. And then that distance will be B over n plus 2. Again, yung n dito is the degree of your curve. And so, diba, if we have a triangle, let's say this one, and this is B, this is H, diba, yung n natin is magiging 1, or yung degree ng curve. And so, if we will apply this one, we have the centroid dito. And then this distance will be B over n plus 2. B over n plus 2. And then, diba, yung n natin is 1. So, substituting 1 dito, we have B over 3. And so, that's why yung centroid ng triangle patungo sa height is 1/3 ng base. Kasi, diba, ito yung tinuro sa inyo sa mechanics. Now, sir, what if rectangle? Pwede ba namin gamitin as baseline? Pwede. Diba, if you have a rectangle, this will be your base, and then this will be your height. And then, diba, yung centroid is nasa gitna lang ng rectangle. And so, diba, again, yung n nito is 0. So, using this one, we have B over n plus 2. And then ito, magiging 0. So, magiging B over 2 yung moment arm. And so, diba, this is just located along half ng base. Kasi this will be B over 2. And so, that's where it comes from. if ever you will forget, itong dalawang shapes lang din yung baseline mo. Now, what if, sir, the degree of the curve is 2 degrees? Let's say, this is a second degree curve. Ano yung mangyayari? We will be substituting 2 dito. And so, this will be b over 2 plus 2, which will become b over 4. So, ganyan lang. And then, if that's 3, magiging b over 5, and so on. Now, meron din tayong general formula for this distance from here patungo sa centroid. However, hindi ko na lang yan sinalay kasi pwede lang naman ito yung i-memorize mo kasi this distance will just be b minus this distance. Or ilalagay ko na lang, this will be b minus b over n plus 2. And so, diba, this will just reduce into b times n plus 1 and then over n plus 2. Now, sir, saan to galing? Pwede natin tong i-simplify. Kasi diba, this will become, if n plus 2 is our common denominator, we have n plus 2 dito. And then, for the first expression, we have n plus 2 divided by 1 and then multiplied by b. And so, that will be n plus 2 divided by 1, magiging n plus 2. And then, n plus 2 times b, magiging b times n plus 2. And then, n plus 2 divided by n plus 2, magiging 1. And then, times b, magiging b. And so, this will be minus b. And so, if we will factor this one with b as our common term, we have b times n plus 2 and then minus 1. Diba? Kasi b times n plus 2 divided by b will be n plus 2 and then negative b divided by b will be negative 1. And this will be over n plus 2. And then, diba, n plus 2 minus 1 will become n plus 1. And so, that's why this will be b times n plus 1 over n plus 2. Now, you can memorize this one if magaling kang mag-memorize, or you can just look at the figure and then simply use this one, b minus b over n plus 2. Now, nung college pa ako, ito lang talaga yung ginamit ko. And then also this one. But feel free to use this one if it's more convenient for you. And so these are the general formulas that you have to remember whenever you're solving for the shear and moments in beams. And so now, let's try to proceed to our first problem. Let's say we have a trapezoidal load acting sa cantilever beam natin. And so, let's first identify our reactions. Now, diba, if we have a cantilever beam, we have 3 reactions. Isang vertical, isang horizontal, and isang moment reaction. Now, yung reactions nito, nilagay ko na beforehand. But I will show you how these were obtained. And then, diba, sa first step natin, we have to assign letters where there are changes in the loading. And also at the ends of the beam. Now, since this is the left end of our beam, we will label this as, let's say, A. And then dito, merong change in the loading. Kasi this point is where our triangular loading stops. Kasi diba, it starts from 0 dito, and then increases to 10 Newton per meter. And so we will label this as B. And then, we have a uniformly distributed load. So, walang change in loading dyan. However, we have a force dito, which is 40 newtons. And so, this will be our point C. Kasi merong change in loading dito. And then, dito sa point where our distributed load ends, this will be point D. Another letter na yan. So, this will be D. And so, itong fixed support, this will be our last point. And so, let's label this as E. And so now, we can compute these reactions. Itong 5, saka 75. Now, let's first start dito. Kasi this will be easily obtained. We can just sum up forces vertical. And so, diba, summing up forces vertical, we have 40 which acts upward. And then, to make our calculations easier, we will just get the resultant of our distributed loads. Now, again, diba, yung resultant of a distributed load is just its area. And so, to get the resultant of this triangular load, we need to get the area. Now, diba, this is 10 Newton per meter. And so, yung height ng triangle dito is still 10 Newton per meter. Now, this will have a resultant force dito. And then, yung area nito will be, diba, 1/2 times base times the height. And so, yung area natin will be 1/2 times the base, which is 3 meters. And then multiplied by the height, which is 10 Newton per meter. So, times 10 Newton per meter. And so, diba, yung meter magka-cancel. And we will only have our equivalent concentrated load. Now, instead of area, I will just label this as the resultant. And so, diba, this will give us 15 newtons. So, this will be 15. and then N. Ito na yung resultant load for this triangular area. And then, for this uniformly distributed load, diba, this is just a rectangle. So, yung area nito will be base times height. And then, it will act sa gitna ng rectangle. So, let's say, nandito. This will be the resultant, and then, that will be base times height. Now, yung base nito is just 2 plus 1. Kasi, diba, yung load spans over this length. And that's 2 plus 1. So, yung base is 3 meters, and then yung height is still 10 Newton per meter. So, times 10 Newton per meter, magka-cancel yung M, and then we are left with 30 Newtons. And so, ito na yung resultant load of this uniformly distributed load. And so, again, summing up forces vertical, we have 40, this one acting upward, and then minus 15, kasi this is acting downward. So, minus 15, and then minus 30, because this is also acting downward, and then plus the vertical reaction at the fixed support. So, diba, itong 5, this is initially unknown. And so, let's just label that as EY. So, plus EY, and then equate natin to 0. And so, solving EY, we will have EY is equal to 5 newtons. And so, that's why this is 5 newtons. And then, to get the moment reaction, we can sum up moments about E. Now, diba, this will be the moment reaction at E. And so, in our assumption, it's clockwise. And so, we will write that as positive. So, taking moments about E, we have ME, again, positive because yung assumption natin is clockwise. And then, let's sum up the moments about dito sa E. Now, itong 40 newtons, this will cause a clockwise rotation about point E. Now, try to imagine na ito yung hinahawakan mo. And then, if ito yung hinahawakan mo, and then you will apply an upward force dito, diba, the beam will rotate clockwise. And so, that's why yung moment na makukause nito will be clockwise or positive. So, plus 40, and then again, we will multiply the load by the moment arm. Now, yung moment arm is always the perpendicular distance patungo sa point mo. And then, diba, itong force na to, this will form a 90-degree angle with our beam. And so, yung perpendicular distance will be from here patungo dito. Kasi again, this is our load. And it's perpendicular. So, ito na yung perpendicular distance. Now, that's 2 plus 1. And so, we will multiply this by 3. And then next, for the distributed load, we can just use itong resultant. Now, diba, this resultant acts sa gitna ng distributed load natin. And so, if this whole distance is 3 meters, diba, this distance will be 1.5 meters or half ng 3. And then, itong 30 newtons, this will cause a counterclockwise rotation about dito sa E. Kasi again, just imagine that you are holding this one and then you are applying a downward force dito, diba, your beam will rotate counterclockwise. And so, this will be minus. And then, let's plug in our load, which is 30. And then, we will multiply by the moment arm. Now, yung moment arm nito, patungo dito sa E, will be this whole distance. Yan. Kasi diba, this load forms a right triangle with the beam. So, again, this is a right angle. And so, ito yung perpendicular distance from here, patungo dito. And so, that will be 1.5 and then plus 2 meters. Kasi this is 2m. As labeled dito. And so, yung moment arm natin is 1.5 plus 2. And then, we still have our resultant for the triangular load. And so, that will still be minus. Kasi again, if you are holding this one, and then you will apply a downward force dito, your beam will rotate counterclockwise. And so, this will be minus 15, and then multiplied by the moment arm. Now, diba, for triangles, yung resultant acts at the centroid. And then, yung centroid acts 1/3 of the base from the height. Diba, ito yung height ng triangle natin. This one. And so, from here, patungo dito sa resultant or the centroid of the triangular load, that will be 1/3 of the base. So, 1/3 ng 3 meters. Kasi, diba, ito yung base natin. So, 1/3 ng 3, that will give us 1 meter. So, itong distance na to, this is 1 meter. And so, yung moment arm niyan, patungo sa E, will be 1 meter plus 2 meters plus 1 meter, and then plus another 2 meters. And so, ilalagay ko na lang yan lahat. We have 1 plus 2 plus 1, and then plus 2. And then, we will equate this one to 0. And so now we can solve for ME. Now you may simplify this one or just use your calculators. Now using our calculators, we have ME equals positive 75 Newton meter. Now since our result is positive, that means that our assumption of the direction of the reaction is correct. And so this is actually clockwise. And then since positive rin dito, that means our assumption is correct. And then EY is actually upward. And so erase ko na lang to. And so we will first form our shear diagram. And so I will just screenshot this one. I will just continue solving the problem dito sa OneNote so that mas interactive yung discussion natin. Now first, let's form our shear diagram. Now we will label that as V diagram. This is equivalent to the shear diagram. Now again, itong V diagram, this is from our loads. It describes the changes in loading. And so diba, we will start from 0. And so let's project a line from each of the letters kanina. Diba, this is A, this is B, this is C, this is D, and then this is E. Now sir, why are we not including this one? In drawing our shear and moment diagrams, we are not interested in axial forces. And then, if we will use the equilibrium equation, summation of forces horizontal, this will also just be 0. Kasi wala naman tayong horizontal force acting toward our beam. But nevertheless, we will just neglect this one. Now you may ask, sir, why is this an axial force? Diba, this is our cross-section ng beam. If we are viewing it from the side. And then diba, if we have this force, that's acting sa center. And so diba, this force is perpendicular to the cross-sectional area. And so that's why that's an axial force or a compressive force. If we are considering this figure. However, we are not interested in that. We are interested in the shear. Now, diba, yung shear considers the area parallel to the force. Now, diba, yung force natin na vertical will be paganto. And then, diba, if our force acts vertically, then that will be parallel to the area. And so that's why we are only considering vertical forces. I hope clear tayo dito. So again, we will project a line from the points and then we will try to establish our 0 line. Kasi again, yung shear will start at 0 and at 0. So this will be 0 dito and then we will move toward the end of the beam. So until dito. Now again, in forming the shear diagram, we will just look at the loads. Now diba, if we have a distributed load, yung shear from the first point up to the second point, we'll just consider the resultant of the load. From here up to here, we have 0 minus 15. Now sir, why minus? That's because yung 15 newtons acts downward. And so yung value dito will be negative 15 or simply the shear at B. Now sir, ano yung connecting line nila? Will it be a straight line or a curved line? Now in this particular figure, we will connect using a curved line. Now bakit? Now that's because yung degree ng triangular load is 1 degree. And then diba, from the load diagram, we will move 1 degree when we are in the shear diagram. And so yung degree dito will be 1 plus 1, that will become 2. And so we will have a second degree curve. However, yung next question that will arise will be, sir, will the curve look like this one or this one? Yan na yung second question. However, let's just go back doon sa leaf na tinuro ko. Diba, we will draw 2 leaves. One pointing to the right and then one pointing to the left. Diba, ito yung tinuro ko kanina. And so, diba, yung pointing to the right will be positive and then yung pointing to the left will be negative. And so, ito na yan. And then, itong mga nasa right, ito, saka ito, yung nasa right side ng leaf will be increasing. So, this will be increasing and then ito rin. And then, yung mga nasa left side ng leaf will be decreasing. So, this will be decreasing and also this one. And so, ito yung dapat mong tandaan. Now, looking at our figure, diba, we have a triangular load which acts downward. And so, diba, if that acts downward, then that means that we are considering a negative load. And so, we will be considering this leaf kasi diba, negative. And then next, we will consider the magnitude. Diba, our load starts from 0 and then ends at a certain value, which is itong 10 Newton per meter. And so, it's essentially increasing. So, we will consider negative and then increasing. So, we will be considering this curve or simply this one. Itong curve na to. Kasi again, this load is negative increasing. And so, balik tayo. Yung connecting line dito will be forming this curve. And so, paganto na yan. Yan. And then, this curve will be in the second degree. Or itong sinulat natin kanina. And so, let's remove this one. Again, this is point A. This is B. This is C. And then, meron palang D dito. And then, this is E. Now, sir, from B to C, what will be our load dito? Now, hindi pa natin yan alam if the load will be right here or nandito. Kasi we will have to solve that one first. Now, diba, yung shear from B to C will be the shear at B plus the resultant of the distributed load from B to C. And so, hindi itong 30 yung gagamitin natin. Now, bakit? That's because we are considering the distributed load only from B to C. And so, let's just make a new resultant for that one. Again, let's just use purple to form the resultant from B to C. Now, diba, yung distance from B to C is 2 meters. So, we will get a new resultant dito. This is the resultant from B to C. Now, this will be equal to the base, which is 2 meters, times the magnitude of the load. So, that's 10 Newton per meter. And so, diba, yung M magka-cancel, and then 2 times 10 will be 20 newtons. So, yung resultant dito, from B to C will be 20 newtons. And then, that will be downward. And so, from negative 15, we will subtract 20 so that we can get the shear at C. So, mali yung assumption natin kanina. It's not actually dito or dito, but andito. Kasi, negative 15 minus 20 will give us negative 35. Again, we started at 0, and then itong negative 15 is just 0 minus itong 15, which acts downward. And so, kaya negative 15. And then for this one, we have this shear, which is negative 15, and then minus 20, kasi this is acting downward. So, minus 20, negative 15 minus 20 will give us negative 35. Now, sir, what will be the connecting line from here patungo dito? Now, that will be a straight line. Now, bakit? It's because our uniformly distributed load is constant. Now, if constant, diba, yung connecting line will be a straight diagonal line. And then, yung direction, whether up or down, will depend on the sign. Now, diba, yung resultant natin is acting downward. And so, yung line natin will also move downward. So, from negative 15, we will connect a straight line dito. And then, this value will be negative 35. And so, I will just move this one. Again, ito yung shear natin at A, ito yung at B, and then, ito yung at C. Now, diba, as discussed, if meron tayong concentrated load at a point, diba, meron tayong left and right shear values. Now, itong negative 35, this is the left shear value. But since we have a concentrated load, meron din tayong right shear value. Now, diba, yung right shear value is equal to the shear at the left and then plus the concentrated load. Plus or minus pala, depending on the direction. And so, yung shear dito sa right will be this shear, which is the shear at the left. Let's just label this as VL, and then plus the concentrated load. Now, sir, bakit plus? That's because our 40 newtons is acting upward. And so, this will be plus 40. Now, negative 35 plus 40 will give us positive 5. And so, nandito na yung right shear value natin. Let's draw a line patungo dito. And so, ito na yan. This will be 5 newtons. Now, I will just use itong blue line. So, pag ganyan, and then, pag ganito, and then, let's connect a line dito. Yan. And then, from C, patungo sa D, we will subtract the resultant of the distributed load spanning C to D. And so, we will essentially consider this one only from C to D. And then, diba, that will have a resultant of 1 meter times 10 Newton per meter. And so, yung M natin, magka-cancel. And then, we are left with 10 newtons. So, this will be 10 newtons. And so, yung shear dito sa D will be 5 and then minus 10. Now, sir, bakit minus 10? That's because 10 newtons yung resultant ng distributed load natin. And it's acting downward. And so, that's why it's negative. Now, 5 minus 10 will give us negative 5. And so, yung shear natin at D will actually be negative 5. So, andito na yan. It's below the 0 line. So, this will be negative 5. And then, we will draw a line dito. Again, dito yan galing. Yan. Now, from D to E, wala na tayong loadings. Kasi diba, wala nang loads dito. And so, for that segment, wala tayong gagawin. And so, we will just draw a straight line dito. From D, patungo dito sa E. And so, this will still be negative 5. This is your left shear value. Or say, VL. VL at E. And then, this is VL at C. And this is VR at C. Now, because we have a concentrated load dito as our support reaction, this will have a corresponding right shear value. Now, yung right shear value will be, let's just label this as C, and then ito rin, and then this will also be C. So, yung VRE natin will be the shear at the left, or VLE, and then plus or minus the concentrated load. Now, yung concentrated load natin dito is the support reaction, which is 5 newtons acting upward. And so, we will actually use plus. So, this will be plus 5 newtons. And then, yung VLE natin is negative 5. And so, diba, negative 5 plus 5 will give us 0. And so, yung shear natin dito sa last point will be 0. And so, that's how we can tell na tama yung shear diagram natin. Kasi our shear diagram should start at 0 and then end at 0. So, tama na to. Now, kung hindi yan 0, ikaw yung mazi-0. Hindi, joke lang. And so now, since tapos na tayo sa shear diagram, we will move on sa moment diagram. And so, sulat natin dito. This is the M diagram. Now, just like our shear, our moment diagram starts from 0 and then it will end at 0. And so again, at each end, this will be 0. And then let's extend this line. And then 0 din to dito. Now again, to get the moment value from one point to another point, we will sum up all the areas. So the moment value here at point B will be this area. And so let's label this as, let's say, area 1, this one. Now again, this curve is in the second degree. And so if we will compute A1, we can use the formula, which is BH over n plus 1. And then this will be equal to the base, which is 3 meters, because this is 3 meters, and then multiplied by the height. Now our height is negative 15. And so let's write that one. We have negative 15. And then divided by n plus 1. Our n is 2. And so we will substitute here 2 and then plus 1. And so writing this in our calculators, we have 3 times negative 15 and then over 2 plus 1, that will give us negative 15. So this is negative 15. And then this will be in Knm. We know that the shear diagram is in Kn because it only talks about the loads or the forces. And so itong 15, this is in Kn. And since we are multiplying by 3 meters, that will be Knm. Because itong nasa denominator, that's unitless. So again, this is in meters. Para ma-orient na kayo sa units. And so again, we are starting from 0. And then our moment value at point B, which is right here, is itong negative 15. So nandito yung second point natin. Yan. And then this will be 0 minus 15. Because again, MA is 0. And then we subtracted this area. So 0 minus 15 will be negative 15 kilonewton meter. Or I'll just write the unit here. This will be Knm. Ito na lang. This is Kn for the shear, and then for the moment, it's Knm. And so, ito na yung moment dyan. Now, sir, what will be our connecting line? Will it be a curve or a straight line? Now, if we look at our shear diagram, we have a second degree curve. And so, if we add 1, di ba, magiging 3. And then, if our line is in the third degree, then it will still look like a curve. Again, basing it from here, we have n equals 1 degree. And so, plus 1 sa shear diagram, magiging 2. And then plus 1 sa moment diagram, magiging 3 degrees. And then to determine the orientation of the connecting line, we will look at this one. Diba, if you look at our shear diagram, this area 1, this has a curve of negative increasing. Because the magnitude of this one is negative. And then, it starts from 0 and then ends at a certain value. And so its magnitude has increased. And so that means that we have negative increasing. And so our curve will look like this one. Because again, negative and then increasing. So we have this curve. And so let's write that here. I'll just use green. And then ito na yan. This will be a curve. And then yung degree is third degree. Now next, we need our moment at C. Or at this point. Let's just write the points here. This is A. And then this is B. And then this is C. This is D. And this is E. Now to get the moment value at C, we have to add this value and this area from B to C. And so let's say this is our area 2. This whole trapezoid, that one. Now again, just to be clear, our moment at A is equal to 0. And then our moment at B is equal to 0 and then plus A1. And then again, A1 is negative 15. And so that's why we have negative 15. And then to get MC, we have 0 plus A1 and then plus A2. Or simply, our moment value is the total area of this one. And so let's move this one. We have A2. Now for A2, I am considering the whole trapezoid. And then diba, meron tayong formula para dyan. That will be A plus B divided by 2 and then times H. Now we can treat this one as our A and then this one as our B and then we can treat this one as our height. Or if nakalimutan mo na to, you can just project a line dito. And then you can divide this whole area into a triangle plus a rectangle. If ever you forget this formula. But I will just be using this one and then just try to check if you can get the same value. So, erase ko na to. Again, this side will be our A. This is A, and then this is B. And then this will be our height. Just try to imagine that we are rotating the trapezoidal figure. So, this is H. And so, we have A2 equal to, our A is negative 15. So, negative 15. And then we have our B equal to negative 35. So, this will be minus 35. And then divided by 2. And then multiplied by H, which is 2 meters. Again, this is 2 meters. And so we have 2 meters dito. Now, instead of using negative values, you can just use the absolute value. However, you have to take note that if it's under the 0 line, it will be negative. And then if it's above the 0 line, it will be positive. That will be your consideration if you will just consider the absolute value. And so typing this one in our calculators, we have negative 15 minus 35 divided by 2 and then times 2. That will give us negative 50. And so this is negative 50. And then the unit is kNm. However, be wary of this one. This isn't the moment at C. Again, our moment at C will be the total of these areas. And so we have to add A1 and A2. And so we have 0, and then our A1 is negative 15, and then our A2 is negative 50, so minus 50. And so we have negative 15 minus 50, that will give us negative 65. And so from here, we will actually move down if we are going to C. So let's just extend this one, and also this one, and also the rest. Now let's just say that the moment value at C is somewhere right here, because again this is negative 15 and then minus 50, which is negative 65. Now sir, what will be our connecting line? Let's try to look at our figure. Now our figure is below the 0 line, and so we will consider negative, and then we will try to check if it's increasing or decreasing in magnitude. Now that will be easy to identify because here at B we are starting from negative 15, and then right here at C we ended at negative 35, and so the magnitude is increasing. So we will still be considering this one negative and then increasing, and so the curve will also look like this. So from here we will draw a curve like this. Now sir, what will be this degree? Now let's try to check here. Again, this is a trapezoid, but you can divide this into two areas, one rectangle and one triangle. However, what we will be considering is the figure with the higher degree. Now we know na yung higher degree dito is yung triangle, because yung n will be equal to 1. Because if rectangle, our degree will be 0. And so what we will consider here is n is equal to 1 for this line. And so if n is equal to 1 dito, then n must be 2 dito, because 1 plus 1. So this is in the second degree. Now next, as you can notice, at this point, there is a change in shear. And so we will need to project a line from that. So let's project a line from this point. Yan. And then let's try to check this distance, this one and this one. Now we can get that distance by using ratio and proportion. Now we know that this distance is 1 meter, this whole distance. And so let's try to label this as x, this one, from here patungo dito. So let's say that's x. Now if this is x, then this is 1 minus x. Now sir, bakit 1 minus x? Yung whole distance kasi is 1 meter. And then if you will subtract x, you will be able to get this distance. Now conceptually, you can directly get this value, because this value is 5 newtons and this is also 5 newtons. And so essentially, 1 meter will just be divided into 2. However, I'm using this one because you need to learn how to compute x if the loads are not equal. And so we will just use this solution. So using our ratio and proportion, we have y is to x. And so yung y for this triangle, this small triangle, that's 5 newtons. So that will be 5 and then over x. And then since this is just one line, the slope here will also be equal to the slope here. And so we can equate this one with this triangle. Let's say this is our second triangle. And so that will be, the height is 5, and then our base is 1 minus x. So 1 minus x. Again, to avoid confusion, this is the height divided by the base. We are considering this ratio. Now, if we will use our calculators, we have 5 over x is equal to 5 over 1 minus x. And so our x will be 0.5. So this is actually 0.5 meters, and also this one. Because 1 minus x or 1 minus 0.5, that will give us 0.5. So 1 minus 0.5, that's 0.5. Now since we already have this distance, we can compute this area. Let's say this is our area 3. Now our area 3 will just be 1/2 times base times the height. And so that will be 1/2 times the base, which is 0.5 meters, and then multiplied by the height, which is 5 newtons. So times 5. And so this will give us 0.5 times 0.5 times 5. That will be 1.25. So this is 1.25. And so let's say this is point F, because this is a new point. So let's just also say that this is F. Now since this is a small value, let's just extend this one to make our figure realistic. And so our MF will be 0 plus A1 plus A2 and then plus A3. So that will give us A1 plus A2 is negative 65. So we can just write this one as negative 65. So minus 65, and then plus A3, which is 1.25. So 1.25. And so we have negative 65 plus 1.25, that will give us negative 63.75. So minus 63.75, and then KNM. And so from negative 65, we'll move up. So negative 65, and then plus 1.25. That will give us negative 63.75. Now sir, what will be our connecting line? Let's check our V diagram. Now this degree is 1 degree, because this is a triangle. So if n here is equal to 1, then our n here will be equal to 2, because we will be adding 1. And then sir, what will be the connecting line? Let's try to check our leaves. Now this is positive because it's above the 0 line. And so we will consider this leaf because this is positive. And then we will check the magnitude. Now we are starting at 5, and then up to point F, we have moved to 0. And so the magnitude is essentially decreasing. So we have positive and then decreasing. And so our curve will look like this one, this curve. And so this will be our connecting line. So let's zoom out. This is our connecting line, and so we have this one. We will draw that line, and so it will look like this one. And then if we will compute the shear at D, we have to subtract this area. Let's say this is our area 4, and so our area 4 will be 1/2 times base times the height. Now since these are the same triangles, then we can say that A3 will be equal to 1.25. However, it's negative because it's below the 0 line, and so our A4 will be the same as this one but negative. So 1/2 times 0.5, and then times negative 5. So that will give us negative 1.25. And so to get MD, we have 0 plus A1 plus A2 plus A3, and then plus A4, or this is simply the moment at F plus the area of the shear from F to D. So this is also MF, and then plus or minus the area of the shear diagram from F to D. You can interpret it as this one because this is what I discussed earlier. But this is the more intuitive solution. We are just essentially adding all the areas. And so yung MF natin magiging negative 63.75. So negative 63.75, and then plus or minus the area of the shear diagram from F to D. Now that will be this area. So that's minus 1.25. So minus 1.25, and so this will give us negative 65. And then our connecting line will be negative increasing because this is below the 0 line, and then the magnitude is increasing. So our curve will look like this one. And so let's draw a curved line here, and then this value will be negative 65. And then next, we have to get this area. Let's say this is our area 5, and so we have this one. Now A5 will just be the area of this rectangle. Now again, the base is 2 meters. So this is 2 meters. And then our height is negative 5. So we have A5 is equal to the base, which is 2 meters, times the height, which is 5 newtons. And so we have 10 Newton meter. Now medyo may mali tayo dito. This is supposed to be newtons. Sanay kasi ako sa KN. Sorry. But nevertheless, our values will not change. So this is N, and this is supposed to be NM. Yan. And then just disregard these units. This is also NM, and also this one. And then ito rin. And so again, our A5 is 10 Newton meter. So from here, from negative 65, we will subtract 10 because this is below the 0 line. So that will be negative. Now this is what I meant kanina, na you can just use the absolute value and then just check if it's below the 0 line or above the 0 line. And so this is essentially negative because it's below the 0 line. And so to get ME, we have the summation of these areas. We have MD, and then plus or minus the area of the shear diagram from D to E, or A5. And so we have our MD is negative 65. So minus 65, and then minus 10 dito because it's our A5. So minus 10. And so this will give us 75. Negative 75. And so from here, we'll move to negative 75. And so I will just extend this line. So dito, and then up to here. And then this is negative 75. Now sir, bakit ganito yung line? Now that's because we are considering n equals 0. Because this is a rectangle. So n is equal to 0 here. And so plus 1, our degree dito will be n is equal to 1 degree. Or a straight line going downward. Now sir, bakit hindi 0 yung nasa end dito? Diba sir, sinabi mo kanina na it should start and end at 0? Now this is because we have a moment reaction here, which is 75 nm. And then clockwise. Now, diba, if there is a moment reaction, then we have left and right moment values. And so again, itong negative 75, this is the left moment value. And so let's just label this one as say MEL, or the left moment value at E. Now to get MER, we have to add MEL and then plus or minus the reactive moment or the moment load. And so we have our MEL is negative 75, and then our reactive moment or moment load is positive 75, because again this is clockwise. So plus 75, that's our reactive moment. So negative 75 plus 75, that will give us 0. And so from here, we will draw a line up to 0. And so this means that our diagram is correct because we started at 0 and then ended at 0. Now again, kung hindi mo to mazi-0, ikaw yung mazi-0. And so yan lang talaga yung dapat mong tandaan because our beam is in equilibrium, and so the start and end values of moments and shears should be 0. So yan lang mga Lodi. Now let's try to tackle more examples sa next videos natin. Now again, I will just zoom out so that you can see our solution. Yan.